So as you start into this new module, you're going to be talking about radicals. So this is the radical symbol. It is not a division house. Okay, so you are dealing with a radical. You have an index that goes up here. Okay, that'll be a number right there. So if there's not one there, it's a 2. So any other number that's there, you have the ability on Desmos, if you'll hit the functions button and you scroll down, the symbol looks like a radical with an N right here. Now, as we did our factoring with cubes, you've already known that that was there because we had to take cube roots of things. So now in this new section, we're talking not just about perfect squares, but also perfect cubes, and those you have seen. You also might need the perfect fourth roots and the perfect fifth roots. So what I need you to do is on a spare sheet of paper that you will be able to use when you take the test on this section, all right, the test on this module, you want to write all of those down so that you have them at your fingertips to be able to use. So you can pause the video, make sure you get all those copied. Now, this first set of examples that you have right here, you're always going to want to check to see if they're perfect squares. So you'll go on Desmos and you'll use the square root key and you will type in 46656 and you will get an answer of 216. What that means is this is your answer. This is what you would type in online. And what this means is, because this is not in our actual list up there, because I'm not going to go up to 216, but what that means is that when you multiply 216 times 216, it'll give you the 46656. All right, that's what that means to be a perfect square. Now, on this other one, we have the fifth root. So you're going to go and find this symbol in Desmos. It's going to pop up and look like this, and you've got to type the 5 in over here, and then you'll do 1889568. And when you do that, you end up getting the number 18. No, excuse me. Yes, 18. Okay, so that would be the answer that you would type in online. And again, what this means is if I do 18 times itself again, and one more time, so 5 different times, you will get that number, the let's see, how big is that? 1,889,568. So you always want to check those perfect squares to begin with, and perfect cubes, perfect fourths, perfect fifths, and that index can be any number at once. Now, another thing that I need to talk about is if the number that is in there as an index is 2, 4, 6, 8, okay, so if they're even, they have to be positive answers. That doesn't have to be the case for the 3, 5, 7, 9s, okay? These are odd. Those can have negative answers as well. So these can be positive or negative. So that'll come up a little bit later. So go try the next 2 questions that you have for practice. See me if you have questions. When you finish with those 2, this video continues on to the next page. So if they're not perfect radicals, if it's not going to type in, so you can check it. If you do the square root of 72, you're going to get a decimal answer. So what we're doing now is determining what the index is. So I'm looking at my perfect squareds list, because there is an imaginary understood 2 to be right there. You're not going to see those written very often. All right, so if there's nothing there, that means that you look at your perfect squares list. So I have 1, 4, 9, 16, 25, 36, 49, 64, and 81. Now, I'm stopping at 81 because 17 is smaller than that. So from my list, I'm looking at these numbers, and I'm trying to determine which of these numbers will divide into the number 72. So I'm going to rewrite 72 as 36 times 2. Now notice, please, that 36 is on this perfect squareds list. So now I'm going to break this apart. So this is the square root of 36 times the square root of 2. But I know that the square root of 36 is the number 6. And then I know that if I do the square root of 2, it's going to be a decimal answer, and there's not much else I can do with it. When we look at the cube roots, we have to look at the other list. So we have 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125, and that's as big as I need to go, because 750 can be written as the product of 125 times 6 and you got to keep that 3 in there. Then we break that apart, so I have the cube root of 125 times the cube root of 6. And I know that the cube root of 125 is the number 5. And then we have the cube root of 6. And I know that the cube root of 6 won't go any smaller because there's nothing on that perfect cubes list that will divide into 6. In this next set, we're going to have numbers that are already outside. So the operation between this is multiplication. All right, so we're going to take 660, and as we check down our list of perfect squares, we see that 4 times 165 will go into that. So the negative 8 is still out front. Then I do the square root of 4, and then I do the square root of 165. So this is negative 8 times 2 times the square root of 165. And negative 8 times 2 is negative 16. And then you have the square root of 165. So you can check on 165 to see if anything else will go into it, but it will not. So when we look at the the fifth root of negative 96, remember that if the index outside is odd, you can have negative numbers. So we keep the 3 that's already out there, and then as we're looking at the fifth root, negative 96 is divisible by 8, so we take negative 8 times 12. So we do 3 times the fifth root of negative 8 times the fifth root of 12. And I know that the 12 won't go any smaller because 8 won't divide into that evenly, and the next biggest one is too big. So we keep our 3. The fifth root of negative 8, if you type that in on Desmos, you're going to get negative 2. And then you're going to have the fifth root of 12. So you multiply 3 times negative 2 and get negative 6. And you'll still have the fifth root of 12. Once we get to the point where we are going to simplify radicals using variables, you're going to break these up into a part that is a perfect square and then the part that isn't. So when I do this, I take the perfect square part, and you don't have to write this down, this is just me giving you notes, and then the other one is just the leftovers. Okay, so these are what happens when they don't go in evenly. So we're going to break this up into I'm actually going to change this into the square root, and then I'll go back and do it with the fourth root. Okay, so I'm going to do 2 questions with this one. So we've got the square root of a to the 13th. So what I'm looking for is how many of a to the 13 can I write and divide by a 2. So a to the 13th is the same thing as a squared times a. So notice that because this number is a 2, the exponents that I have on this perfect square part are going to be divisible by 2. All right, and over on the leftovers, these are what's left. So these are the remainders. All right, so b to the 23rd. Well, 2 won't go into 23, but 2 will go into 22. So if I have 22 on that side, I have 1 left over here, because b to the 22nd times b to the 1st is b to the 23rd. All right, c to the 10th, 2 will divide into 10, so the whole thing goes there. No remainders, so there's no c in the leftovers part. And then d to the 3rd, 2 won't go into 3, but it will go into 2. And then I have 1d left over here. Now, to simplify the perfect square part, you simply divide your exponents by the index. So I have a to the 12th, and the 12 is divided by 2, so that's a to the 6th, because a to the 6th times a to the 6th will make a to the 12th power. On b to the 22nd, if I divide 22 by 2, I get b to the 11. If I take c to the 10th and I divide the 10 by 2, I get 5. And then d to the 2nd divided by 2 is just the variable d. And then we still have the square root of a, b, d. Now, I'm going to do that same question, and it's going to look just like what's on your piece of paper. And the answer is going to be very different because this is not a square root, but a fourth root. So I have a to the 13, b to the 23rd, c to the 10th, and d to the 3rd still. And this time, because my index is bigger, I have the perfect part over here, and then I have my leftovers over here. Now, the index stays the same on both. It doesn't matter whether it's a part that's going to simplify or a part that's going to stay. So as you look at a to the 13th, what you have to do is figure out, well, 4 won't go into 13, but 4 will divide into 12. So if I have 12 of my a's there, I've got 1 in this leftover section. All right, 4 won't go into 23, but 4 will go into the number 20. So that means I have 3 extras over here. C to the 10th, all right, 4 won't go into 10, but it will go into 8. So there are 2 that don't work. And then D to the 3rd, 4 can't go into 3 at all. So all of those are going to be on that side. So again, all you have to do from here is take your variable exponent and divide it by the index. So this is 12 divided by 4 is 3, 20 divided by 4 is 5, and 8 divided by 4 is 2. And then these are my leftovers, so I have the 4th root of AB cubed, C squared, D to the 3rd. These take a minute to get used to. All right, I'm going to do this second example, and then you can go and practice on these and ask me lots and lots of questions. So on this other side, we have the square root of 125, and I know that the square root of 125 is not a perfect square, but I do know that 25 will divide into that 5 times. So 25 times 5 will give me the 125. So I have the perfect square part, and then I have what's left over. So 25 times 5 makes 125. And remember that I have this imaginary 2 out here. So I know that 2 will divide into 4 exactly. So that part goes here. This y has an exponent of 1, and 2 will not go into 1 at all. So it comes over here. And then z to the 5th. Well, 2 won't go into 5, but it will go into 4. And if I have 4 z's over there, then I have 1 left over here. And now I'm taking the square root of 25. That's going to give me the number 5. If I take the square root of x to the 4th, I just take 4 and divide it by 2, so that gives me a 2. And then I take z to the 4th, and I take 4 and divide it by 2. So this is the part that simplifies, and then this other part will not simplify, so it stays the square root of 5yz. One of the biggest problems that kids will have with this is that they forget their index. The second thing you're going to have to do is make sure you're looking at the appropriate perfect list of numbers that you wrote down at the very beginning. See me with questions.